Let's have a look at a key concept in chemistry. And going forward, this is going to become one of your major points every time you look at an experiment or an equation or anything at all, really. And it's called stoichiometry. Now, another way to look at stoichiometry is molar ratios. So molar ratios and stoichiometry is what we're looking at here. And as an example, we are going to look at a very common experiment or common reaction, which is the addition of a carbonate, in this case calcium carbonate, to an acid, in this case hydrochloric acid. And you'll know that that gives us carbon dioxide, water, and a salt. Now you'll also see that this has been balanced. And this is kind of what we're talking about now. So once an equation's been done, that's been balanced, we can look at the stoichiometry or the molar ratios of that equation. So basically, stoichiometry is really just the relationship between the relative quantities of substances taking part in a reaction. What this means is, being relative quantities, we are looking at ratios of whole integers, and we tend to be looking at ratios of moles. For example, we can see that just here we're talking about the coefficients. And what that means is, for every 1 mole of this, now we might have 0.079 moles of it, but if we would have 1 whole mole of that, we would need 2 whole moles of hydrochloric acid to react to get this full reaction. And then if we didn't have, we wouldn't use, so if we had, say, 1 mole of this and 1.5 moles of that, we would not use up that whole 1 mole. We would use up 0.75 is what we would use up. We would use 0.75 mole of this and all of this one here up, all the hydrochloric acid. So, for every 1 calcium carbonate, this is the stoichiometry of this equation here, 2 hydrochloric acids are needed. For every 1 calcium carbonate over here, 1 carbon dioxide molecule is produced, and 1 water molecule is produced, and 1 calcium chloride molecule is produced. Now, we need to look at limiting reagents as well. This is where it actually becomes really important, where we can apply it. So the limiting reagent is the reagent in the reaction, that's the stuff on the left-hand side, the reagent in the reaction that limits how far it will go. When it runs out, the reaction stops. So it's the reagent that runs out first. For the reaction below, if we have 1 mole of calcium carbonate with 2 moles of hydrochloric acid, there's no limiting reagent. Everything will be consumed. Okay, so that's nice and straightforward. However, if we have 1 mole of calcium carbonate with only 1 mole of hydrochloric acid, the hydrochloric acid is the limiting reagent, and there'll still be half a mole of calcium carbonate, because remember, the ratio is 1 to 2. So there's the ratio is 1 to 2. So we've only got 1 mole of this. That means it becomes 0.5. If we have 0.5 moles of calcium carbonate, we only need 1 mole of hydrochloric acid. So that means calcium carbonate in that case is the limiting reagent, and only 1 mole or half of the hydrochloric acid will be consumed. I hope that made a lot of sense. If it didn't, ask questions in the comments below and we'll get back to you as quick as we can. Thank you for watching, and we'll see you next time. Bye now.